Warahmatullahi wabarakatuh, and a very good day to everyone. Okay, we meet again through online. Okay, previously we learned about the spaced and events of the probability, which include how to determine and identify the union, the intersection, as well as the complement. So in this slide, we're gonna learn more about the laws of probability. Okay, basically, of course, in any kind of theory or subject, there are certain laws and rules that we have to follow, which also includes probability. Okay, for probability, there are basically three main laws which can be applied. The first one should be the probability that two events would both occur can never be greater than the probability that each would occur individually. Okay, having said that, for example, it's a union. Right? This is a union. Okay, so what is meant by the first law is the probability that two events will both occur. So let me highlight here. The probability that these two events will both occur can never be greater, means to say that smaller, than the probability that each will occur individually, right? So I mean to say that for this one, I mean to say that for both A and B to occur will never be greater than the probability of A and probability of B individually. So that is meant by the first law. Okay, let's proceed with the second law. So second law mentioned about if two possible events, which are A and B, are independent, then the probability that both A and B will occur is equal to the product of their individual probabilities. Okay. Okay, let's move forward. Okay, for example, right, event A is okay. This can be defined by multiplicative rule. Okay, one condition is event A is dependent to B. So it can be also be defined as this, mean to say A intersection of B, or probability of A and B equals to probability of A times probability of B given by A. But if event A is independent to B, so the intersection equals to probability of A times probability of B. So I mean to say that if the two possible events are independent, okay, this is one case, which is if they are independent, then the probability that both A and B will occur is equal to the product of their individual probabilities, right? So equals to the product of their probabilities. So this is what is mentioned by the law. Okay, next up we have third law, which is if an event can have a number of different and distinct possible outcomes like A, B, C, and so on, then the probability that either A or B will occur is equal to the sum of the individual probabilities of A and B and the sum of the probabilities of all the possible outcomes A, B, C, and so on is 1. That is 100%. So basically, this is something that we have been doing previously. I mean to say that it is the complement rule. Okay. Okay. Let's say this is as we studied before on the complement. So this is the event A, and the complement is the AC. All right. So mean to say that the total of this one A and AC should be equal to 100 or 1. Okay, for example, we have one fruit. It can be any fruit, right? Okay, there are two fruit here. I have an apple. Oh, sorry, not apple. I have a pineapple and I have a pear. So I have pineapple and apple. And then for the pineapple, I have the fresh one, F, and the non-fresh one denoted by F prime. It also applies to apple, which is F for the fresh and non-fresh one. So as what was indicated by the rule, we need to say that the total of the event should be equals to, okay, for example, right, we have one half of fresh should apply to pineapple, and one half equals to the non-fresh ones, and also applies to the apple and the non-fresh one. So actually, but most importantly, the total of the event A, which is the event for the pineapple, should equal to 1. Also, for the probability for the event B, which is for apple, should equal to 1. Okay, the same thing also apply if let's say, we need to say that if let's say this one is third fourth, so of course this one should be 1/4. Okay, so basically that is what is meant by the rule, by the third rule. Okay, let's proceed to the next slide, which is on how to calculate the probability. Okay, as previously mentioned, for the week 2, we learned about the unions, intersections, and also the complements. So how do we want to calculate those? All right, so let's proceed with the calculations. So basically, these are the rules that we have to constantly follow. All right, so for the in order to calculate probability for the unions, so we have to apply the additive rule, whereby for any two events A and B, the probability of their union, which is P A union B, is like this. All right, so this is the definitions and on how to calculate the probability for the unions. All right, so this is the unions. So the union for the probability for the union A and B equals to probability of A plus probability of B minus probability of A intersection to B. Right? So I mean to say that A, this is A, this is B, for example, right? This is A, this is B. So this one plus PA plus PB minus inside here the intersection, because it's going to be a redundant if let's say you include this one also. Okay, so let's move forward. Okay, this is the example. Right, so we just want to calculate the A union and B only without having to calculate the intersections. Okay, I have a question here. Suppose 150 students have been classified as follows. Mean to say that male students are 60, female students are 40, but not for the black hair, and not black hair are 25 and 25 respectively. Okay, suppose A is the student which has the black hair and B is the student is male. Alright, So the question is, what is PA? We need to say the probability of A. Okay, A is the student has black hair. The total should be 150, right? So the total is 150. So we should put 150. Okay, the A, which is the students with the black hair, how many? 100, right? 100. Okay, so should be 100. 100 per 150. So make a small fraction to here, so it can be 2/3. So is it correct? Alright, okay, so next, what is PB, the probability for B? So B is student is male. Alright, they just want to know how many males here. So we have, again, the total should be 150 and how many male students? 60 plus 25, 85. So we have 85 here. Is equals to so make a smaller fraction for this one. Alright. Okay, next up we have probability for A intersection of B. So again, we have 150 and what is the intersection of A and B? Alright, student with the black hair and male. So we have 60 here. So it's going to be 60. Yeah, so make the smaller fraction for this one also. And for this one, probability for A union B. Okay, let's take a look at this formula, which means that PA plus PB minus PA intersection B. Okay, so we can just put here PA plus PB minus P A intersection B. Alright, basically we have all the data here, right? So we have PA here, PB here, and P intersection B. Okay, so just put all the value over here. 100 per 150 plus 85 per 150 minus 60 per 150. So you're gonna get the answer.